Hey guys, Mr. Winslow here, teaching from an undisclosed location. But I just want to teach you a couple more things about the logarithmic graphs before we kind of close this unit out. But look at this graph just to recap real quick. If you want to graph this real quick, just based on our last couple lessons. I know that this is going right to from like the parent function. So basically, what I could do is I could essentially go right to have my little asymptote at x equals 2, right? And at that point, I could just plug in some x's, get out some y's, or put that in exponential form. However you want to do it, but let's say I put in like a 3 there. 3 minus 2 is 1. Log base 4 1 is 0. 0 plus 3 is 3, so 3 would be on that graph, right? I don't know, let's say I put in 3, 4, 5, 6 in that graph, because 6 minus 2 is 4, so that'd be an easy one. So 6 minus 2 is 4. Log base 4 of 4 is 1. 1 plus 3 is 4. And so if I go over to 6, go up to 4, put a little dot, we know it kind of goes like this. Okay. So there's our exponential graph, right? Or excuse me, logarithmic graph. So just a couple other things I want to tell you about this that maybe we haven't talked about. Let's talk about, well, domain on this when we talk about that is going to be x is greater than 2, right? The range of this graph is going to be all real numbers. So if I write this like, so domains x is greater than 2, range is all real numbers. A couple things we haven't talked about were the x and y intercept. So remember, the way you find x and y intercepts is if you want the x-intercept, you could put a 0 in for y, right? If you want the y-intercept, you could put a 0 in for x. So I'm going to let you guys know right now, this one right here doesn't have a y-intercept, and you could check that out. If you put in a 0 in for x, you get a -2 here. You can't have that, right? But if you want to find that this x-intercept right here, it doesn't have a y-intercept, right? If you want to find this x-intercept right here, all you'd have to do is put a 0 in for y. What you could do is you could put a 0 right there, right? And you could solve for that x, right? So if you want to solve for this x, what you would do is you would take that 3, bring it over, so -3 equals log base 4x minus 2, right? At this point, you'd want to put that into exponential form. So 4 to -3 equals x minus 2, and then add the 2 over. So 2 plus that number is the x-intercept, right? Now, do y'all know what 4 to the -3 is? Well, 4 to the third would be 64. So 4 to the -3 would be 1 over 64. So that point right there would be 2 and 1/64th comma 0, which makes sense because as we get close over here, this gets closer and closer to this asymptote, which is 2, right? So you should be able to find the x and y intercepts based on what we know about logarithms and exponential functions, right? But the one thing I really want to show you about today is looking at this function right here and finding the inverse of it, okay? So if you remember, finding the inverse functions, basically the x's and y's flip. So everything about this graph, the x's and y's will just flip, okay? And what I want you to notice is the inverse of this should be exponential in nature, right? So instead of looking like this, it should kind of look like this, okay? So essentially what I want to do is just take a minute and find the inverse of this function. So the inverse of this function right here, here's what's going to happen, okay? The inverse of this function is what you're going to do is you're going to take the x and y and flip them. So basically, you're going to do this, right? And like all functions, we kind of want the y isolated. So in order to find the inverse of this, you're just going to have to isolate that y. So the first thing you want to do is bring that 3 over. So how do you bring that 3 over? You subtract, right? So you have this. Then at this point, you could put it into exponential. So 4 to the x minus 3 equals y minus 2. And then finally, just add the 2 over, right? If you add the 2 over, you get 4 to the x minus 3 plus 2 equals y. Okay? And what I want to do is I want to show you that this is actually the inverse of that one we just did, right? So think about that graph we just had, right? I'd like to graph this for a minute and see what we get. So first off, remember how exponential functions, they had asymptote y equals 0. Well, this is going to be up 2. So essentially the graph is going to kind of do this. Let me show you. The graph, let me turn this over just a bit here. The graph is going to be up 2, so we're going to have an asymptote at 2. Remember how or y equals 2. Remember how the other one was at x equals 2? That's totally flipped, right? Now, we have 4 to the x minus 3. You can put in any numbers you want, right? But let's say you put in a 0, right? Well, 0 minus 3 would be negative 3. 4 to the negative third is 1 over 64. 2 plus 1 over 64 is 2 and 164. Do you recognize that number? You should. That was the old x-intercept. Well, guess what? Now that's the y-intercept, right? And we could plug in a couple points like we did a minute ago. Like, say you plugged in a 3, right? 3 minus 3 is 0. 4 to 0 is 1. 1 plus 2 is 3. So, I mean, you could graph. You're welcome to graph that on the calculator. But a couple points, like say a 3, you put a 3 in, you get a 3 out. That point was on the other graph, and essentially, it's just going to go up like that, right? You'll note what you'll notice is that graph we just did a minute ago. Essentially, that was right here. Essentially, what you have is a reflection of that line y equals x, right? So you can see that they are both reciprocals, or excuse me, inverses of one another. So basically, what happened from this graph, from this one to this one, is the domain and the range totally flipped, okay? Here, the domain is x has to be greater than 2, right? Here, the range is y has to be greater than 2. Here, the range was all real numbers. Here, the domain is all real numbers, okay? Here, you had the point, what was it? You had the point 2 and 1/64 comma 0. Here you have 0 comma 2 and 1/64. So basically every point that was on this just got flipped to this. So what I'm going to ask you to do, just to kind of shore up this relationship in your brains, is just get a couple of these, graph them, and compare them to their inverses, okay? So y'all check for your homework tonight, but I hope this video helps. I hope you guys are staying safe and doing all your homework, okay? So I'll talk to you next time. See ya.